What's up, everyone? Welcome to Wired Roots. My name's Andrew Gascon. I'll be your guide on this channel. We're just getting started out. This is one of the first few videos I've recorded. So, on this channel, we're going to be looking at some electrical engineering, since that's my background. Mix it in with some, organic farming and all of the stuff that you have questions for. Behind me, I got these composters. I picked up 7 of them to test for you guys, right? So we're going to walk through. A few of them don't work. I'm going to rebuild, figure out what's wrong, repair them. If nothing else, we'll just do a complete teardown. So maybe the broken part you can fix at home. We're just getting started here, so I'm open to all sorts of different suggestions. If you guys see something that you want me to do or think that it would be a good idea, drop it in the comments. That way I have some cool ideas to give to you guys. Thanks for joining, and we'll move on to the first project. First project, as I said, was the electric composters that we're going to start off with. We're going to do an in-depth guide on how to make the ideal soil. What you'll notice with these, I've had them for about 3 months. I've had one all the way over here, the mirror, for about 3 months. That's really what got me started. So I learned a lot just going through that one. It's been running practically every day. I've been experimenting with different mixes. I figured out that you add a lot of water, wetness, it takes a little bit longer. And then also the amount of fiber, the amount of sugar. I turned something into essentially a fruit roll-up or Laffy Taffy. That was interesting. And you kind of want to avoid those kind of things. They make for a big cleanup. So what I'm really interested in, being an electrical engineer, is the power usage of these. Most of them are rated at 500 watts. Now, is that 500 RMS? I'm not sure. So what I'm curious about is what you put in, how much power does it draw? You have things like the torque of the motor. These are super high gear reduced blades that don't spin fast, but spin with a lot of force. So whenever they get bound up on a lot of fiber, it's going to pull a lot more current and a lot more energy. So we're going to do some tests on that to see if high fiber content actually pulls more electricity. The next thing is water content. Think of it like you're boiling a pot of water. Every bit of energy goes into that water to evaporate it out of your compost on these electric composters. So I got a scope behind me here. I got some power meters, some multimeters. We're gonna hook up. What I'm thinking of doing is getting an Arduino, writing some programming code to monitor the humidity. So out of these, there's always a fan that blows the humidity out, right? So we're gonna take this Arduino, close the loop on it, figure out how much humidity is coming out. Because there's a point to where it's done, but the thing keeps running. None of them have the smarts that I have. Well, after we get through, we'll figure it out. But none of these ones, I believe, have the smarts to shut the system down. So we may not shut it down. We may run it for the whole life and then run the calculation to say, here is the optimum point. And, we'll try to pull out the material, test it to make sure that it's actually dry. So that's concept that I have. Let me know if you're interested in that. Moving on to the second project on this channel. It's going to be a mini split. And if you don't know what a mini split is, it's a heat pump. I have one on the house right now. It's a 36,000 BTU. BTU is British thermal unit. And that just corresponds to amount of heat that you can extract, right? So I use it for heating and cooling. My house came with electric baseboard when I bought it, and I had a $583 electric bill. I will never forget that. That was 4 years ago, and I still haven't forgot it. So this thing paid for itself. That was in 1 month. This thing paid for itself in the first year. And I'd like to share that with you guys. My experience with it, what I think about it. I've had a couple of issues, but nothing major. So I'm looking at installing another one onto the nursery as well as the master bedroom. I'm building a closet in the master bedroom on the end wall. We're gonna mount one up there, and I'd like to walk you guys through that process on wiring it up and getting everything configured. Also, I'd like to walk you through choosing the right one. So the model that I chose is different than the previous one that I have on the house for a number of reasons. I had a calculator that I ran for cost efficiency. Big one is efficiency. You have your SEER ratings, your heating ratings, and those are very confusing. So I'll walk you through some of these ratings and what they truly mean. And I figured that out on my previous unit, and it paid for itself. What you don't want is to rely on it for heating in cold weather and it not actually provide that. So some of them are built for it, some of them are not. Some are inverters, some are not. So I'll walk through the different technologies, and then we will go through the installation, and then finally I'll show you the finished product. Third project is general wiring, and I talked about this earlier. General wiring of that system, as well as getting into some software. So I'm not sure how interested people are anymore with software with AI, so I may do just a little bit and dabble in it, kind of show I'm an embedded electrical engineer, so kind of where the rubber meets the road, right? So I'm programming in C, C++, some Python. And all of this is embedded. Arduinos I don't use professionally, but they're just so simple to get things set up. I got, 3 here, so figured out if I'm gonna do it, I might as well show you guys. If I get a lot of likes and subscribes and you guys like it, I'll continue to do it. You just have to let me know if you like it. But yeah, so if any of that sounds interesting, please hit that subscribe button for me, and we'll get these videos rolling for you guys. So I'll see you in the next one.